Welcome back. This is Rashid. Today we are going to talk about timing constraints. Uh, Not the methodology. Okay, just keep in mind that all the methodology related things, why we need timing constraints, how we apply them, what is setup hold time, what is the timing path, what is a timing arc, what are different type of timing constraints we apply, why we apply them, if a path is unconstrained, how you can gradually constrain it. I have covered all that under different topics within the playlist SOC physical design. I think that's the name, yes. So please go into that playlist and watch different topics. And I also cover standard cell libraries and how timing information is stored there for each standard cell. The whole point of doing that SOC physical design series was I kind of cover most of the methodology related items and conceptual explanation. This video and this video series, which is RTL2 routing, is about flow. Okay, how it's source in the flow, what exactly is the tickle file, what is the tickle construct and all that. So that's why I'm going to focus on the tickle here, and I will give a little bit overview of this constraint and how this constraint is created, but I'm not going to go into methodology type of things. So watch those videos for that. Alright, so here you see all the steps that I will go over in the RTL2 routing. So we did library setup, we did design read, and now the third step, timing constraint. Now we have a design. What we have done so far is an intermediate technology independent translation or transformation. And now we have at least design, we have its ports, we can start giving different type of timing, power, and area constraints. Got it? All right, let's jump into that. Where you are right now, okay, you are, keep in mind, sitting, your present working folder is this one. You are inside this one. This is your whatever training folder, whatever you call it. Inside, I expect flow script, design, constraints, and work. Each day you can come and create a different work and then jump into that one. But one folder up, you will be sourcing these things. Okay, so here is my top level flow looks like. I call it my flow article, and this is how I have a design name, which is a counter. I design library name. The library, remember the very first step was creating a library. I create the library. I just use the design name and append underscore lib to it. Okay, so counter underscore lib will be the name of the library, and this is how you can kind of, with curly brackets, just call it this one. If I don't do it, what will happen? It's gonna see design underscore name underscore lib as a whole variable. Okay, this variable I define, I'll show you later on. Sometime you can do some if else here. You want to skip something or not, because keep this in mind that as you start building or creating your flow, sometime you're not just sourcing the entire flow file. You don't have the top level file. I'm creating it gradually. So you have to really source these commands manually inside the vendor shell. So again, we are already in the vendor tool shell, and that's where we're going to run this command. So this was my lib setup article, my short in it. I mean, initially I had a very lengthy version of it, but then I remove some of the unnecessary stuff and just call it my short. So maybe let's, from here onward, instead of calling a lib setup, this is my short init the article. And so this is one NDM creation. I should call a lib creation, not NDM creation. But this is a redesign, sin redesign, and you see one folder up in the flow scripts, I call it. So I'm sitting inside this work folder, one of these work folders. Now, constraints I divide into two. What is the scenario creation? This is pretty recent thing. You have to create all those scenarios. Although I will tell you, I have a very simplistic scenario right now in this design, and that's how you need to start. Start with a simple, and then gradually you can create more scenario, and I'll explain the scenario in a minute. And then the timing constraints you need to read, and I call them design underscore. I already have a file created with counter underscore tcons. Tcon means timing constraints, the article file, and it's inside constraints folder, which is here. Okay, so in this video we will talk about, and maybe we'll do another part, we will talk about these two steps. Okay, I call them both them timing constraint. So this is your create set scenarios. So again, for if whenever inside your script I use this one, and at the end I use this one, and in between I create a code. So mode can be, it's your design is configured in, so your design has a different modes. So think of it as test mode, JTAG mode, functional mode, or maybe functional. Within functional, you have different modes. And what do you mean by modes? Okay, let me think of how simply I can explain you right now. I didn't think of that before, but sometimes the connection in the design through the multiplexers are such that in a particular mode of chip bring up or chip usage or chip testing, based on certain modes through multiplexers, you can give some select signal in such a way that maybe only slow clock goes to the flip-flops, and maybe design is connected and scan chains. I will told you. Okay, this is a very good example. Later on it will come. So I will show you a scan chain mode. Okay, so in that way you can have a connection configurable inside your design that you can put it in a particular mode, and then your tool will be doing more optimization only for that mode. Right now in my case, I don't have different modes. I have a simple counter. Yes, I will have a scan going through it, but right now I'm just doing a general optimization, and that's a good start for me. So I just call that create mode combine, and I call that column. Okay, column, what is column? I remember, I think I have a video under SOC physical design about what is a PVT, P process, V voltage, T temperature. So when you are reading multiple PVTs, that you need to really close your design in different one, and different one have different voltages, temperature, and have a different timing and power constraints, right? So right now I'm only reading single process voltage temperature file, so single timing library I'm using. So just making things simple. So I have one mode, one PVT, and the scenario, I think even if I don't create it, it's okay because I'm just providing single PVT anyway. But I've seen that sometime later on reading some of the net TLU plus, when those come into the picture, you need to have a scenario defined. So I thought, okay, let's explicitly create it as a scenario. So I create a scenario. I call it mode is this combine. I mean, sometimes when you have multiple modes, you can put which mode you want. And then we have multiple corner, you can put which corner you want. So combine main, and I'm calling it this, the name for this scenario is combine, combined, I should have called it, rather main PVT. And current scenario, then I'm saying that, okay, this is my current scenario. I mean, I don't have any other scenario, but sometimes it uses default, which is nothing defined in this one. So I explicitly call it, this is my scenario. Okay, now here's the thing. There are variations on your chip. Okay, transistor width, okay, width of your poly, width of your different metals, width of different vias, width of different length of different diffusions, different shapes can vary a little within the chip from one transistor to another transistor based on the photolithography or the equipment, on the light intensity, or how much concentration of doping here and there. Threshold can vary, width of the transistor can vary, length of the transistor can vary, metal shape, their height or the width can vary, and all these whether interconnect or whether your base layer, they can result in changes in transistor characteristics or metal characteristics, and which means can changes in delay of metals or delay of the transistors, okay, and as well as power. Okay, so these variation within a chip, you can have a variation. Okay, these variations can, based on your standard cell library, you will get one delay, but actually in silicon you might have a slower or faster. Okay, even within slower you can have some faster, little faster, some little more slow, right? There is a distribution. So to model that, We call that on-chip variation. And to model that, we use some d-rates. Means we, whatever delay is by default, we multiply with another 10% increase. It's just called guard banding, putting an extra margin there. Okay, and for that, when it's on-chip variation, single one, we use fixed d-rates. Like we the entire design, my setup on the launch path have more delay but more than 10%. It's like you're building an internal margin in just to prepare yourself for any surprises on silicon, right? Okay. So then, okay, I think what we need to do is, when I explain that, let's stop this video here. And this counter dot tickle, this is the timing okay, this is not a, it's now I call it t oops t cons dot oops on dot tickle. This is the file where my all the constraints are, and I'm going to explain you next time because it's already been 9 minutes or 10 minutes. Okay, all right, sounds good. See you in the next video. Bye.